Yeah. Good evening, children. Evening. Good evening, online students.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good
Good
evening, ma'am.
evening. Good evening.
Good
I've
evening.
shared my screen. Good evening, children. I've shared my screen. Is it visible? Online children?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. So the first one, if sine theta plus sine square theta is equal to 1, don't write anything. Find cos square theta plus cos theta to the power 4. Okay. If sine theta plus sine square theta is equal to 1, that's given to us, right? So sine theta is equal to 1 minus sine square theta, correct? Sine theta plus sine square theta is equal to 1 is given. We know that 1 minus sine square theta is cos square theta. See, if you transpose sine theta, what will you get? You'll get 1 minus sine theta. That's not going to help you. If you transpose sine theta plus sine square theta is equal to 1. If you transpose sine theta, you will have sine square theta is equal to 1 minus sine theta. But if you transpose sine square theta, we know that 1 minus sine square theta is cos square theta, right? So will 1 minus sine theta give you a result, or 1 minus sine square theta give you a result? 1 minus sine square theta gives us a new result, cos square theta. So we transpose sine square theta to the other side because it gives us a new result. 1 minus sine theta is not going to give you anything new. It's going to remain 1 minus sine theta. So you can remember like that. So we transpose sine square theta because 1 minus sine square theta gives us a new result, cos square theta. So sine theta is equal to 1 minus sine square theta. So sine theta is equal to cos square theta. Okay, this is the result. Have it. Now, we have to find cos square theta plus cos theta to the power 4, right? Take that. Cos square theta plus cos theta to the power 4. All right. Now, cos square theta is good in the sense we have this identity sine square theta plus cos square theta is 1. So the power 2 is fine actually. This power 4 will not be useful for us. Okay, so we'll change that. So we'll write cos square theta as it is. Okay, because all the identities have power 2. The ratios and the identities, trigonometric identities, have power 2. No, sine square theta plus cos square theta is 1. Secant square theta minus tan square theta is 1. The power is 2 everywhere. Power 4 we don't want. We are not comfortable. So we'll change that. So you can write it as cos square theta the whole square. Right? Correct? Okay. Now don't disturb this cos square theta. What is comfortable? Why do you disturb? Power 4 is not comfortable. So you change that. So now what is cos square theta? Sine theta. Don't change everywhere. Wherever it is not comfortable, change only that part. So what is, don't write this cos square theta sine theta. See, cos square theta sine theta, right? Don't write this cos square theta sine theta. Cos square theta is good. So it's not a condition that you should replace everywhere you have cos square theta. You should replace sine theta is not a condition. Wherever you want, you can replace. If you want to replace, otherwise don't replace. Okay, you will not go wrong that way. Okay, so here this cos square theta will replace with sine theta because cos square theta is sine theta. So sine theta, correct? But there's already a square here, no? So it will be sine square theta, correct? Now what is cos square theta plus sine square theta? 1. So the value of this expression is 1. The value of this expression is 1. All right? Okay, so we'll see it again. See here, we are given that. We are given sine theta plus sine square theta is equal to 1. We'll transpose sine square theta because we know 1 minus sine square theta is cos square theta. So 1 minus sine square theta. So this gives us a result, a new result. Sine theta is equal to cos square theta. Have this. Now you have to find the value of cos square theta plus cos theta to the power 4. So we'll write it as cos square theta the whole square. Now here we have cos square theta. Here also we have cos square theta. Don't write sine theta in both the places. Don't write sine theta in both the places. This is good. Write this cos square theta. Good meaning the power is 2. Comfortable. Write it as this plus. Here write this cos square theta as Sine theta. Sine theta. Now there's the power 2, no? So sine square theta. So cos square theta plus sine square theta is 1. All right. If x is equal to a cos cube theta and y is b sine cube theta, prove that x by a to the power 2 by 3 plus y by b to the power 2 by 3 is 1. So we have an expression for x. X is a cos cube theta. What's y? B sine cube theta. You will have to prove that the value of this expression is 1. The value of this expression is 1. All right. So now here we have x, right? You can replace this with what? A cos cube theta, correct? By a as it is. This xc, prove that. So take the LHS. Take the LHS. Now for x, you can write a cos cube theta by a as it is. Plus, what is y? B sine cube theta by b. That's the LHS. I have it on the next slide. So see here, x is this one by a plus, oh, this is y. I've made a print, meaning typing error. This is y, children. Okay. So y is what? B sine cube theta. You can see it here by b. So what happens? A gets cancelled. B gets cancelled. And now by the law of exponents, when the base is raised to many powers, we have to multiply the powers. When the base has many powers, more than one power, multiply the powers. So it will be the power, the base is cos theta. The power is 3. And again, there's another power 2 by 3. So multiply the powers. 3 into 2 by 3. Yes, this is y, okay? This is y. So the base is cos theta. It's raised to the power 3. And the whole thing is raised to the power 2 by 3. Right? So 3 into 2 by 3 plus denominator is gone, like it's 1. So there's nothing in the denominator. And here again, sine theta is the base. Multiply the powers, 3 into 2 by 3. So 3 and 3 gets cancelled. So we have cos square theta. Is it visible, children? Okay, so we have cos square theta because cos theta the whole square. Sine theta the whole square. So cos theta the whole square is cos square theta. Sine theta the whole square is nothing but sine square theta. And cos square theta plus sine square theta is 1. So we just have to substitute x given in the question and substitute y given in the question, cancel and simple. Okay. So we have an expression for m. We have an expression for n. And you should show that mn is equal to 1. The product is 1. Mn is equal to 1. The product is 1. So multiply. So what's the LHS? Mn, right? The left hand side is mn. So what is m? This one. What's n? This one. So you'll have to do this into this and show that the answer is 1. Correct? Okay. So this is simple. This is m. This is n. And this is of the form a plus b into a minus b, which is a squared minus b squared. So cosecant theta the whole square minus cot theta the whole square. A square minus b square. Cosecant theta the whole square is nothing but cosecant square theta. Cot theta, b square, cot theta the whole square is cot square theta. And cosecant square theta minus cot square theta is 1 by the identity. Proved. All right. So here a cos theta plus b sine theta is 4. A sine theta minus b cos theta is 3. Find a square plus b square. So you can do this in more than one method. Okay, I have worked only in one method. Okay. You can do this in more than one method. One is you can write the equations one below the other. Okay, so all of you have learned linear equations in a pair of linear equations in 2 variables at school. Yeah, so then you know it. So a cos theta plus b sine theta is equal to 4. A sine theta minus b cos theta is equal to 3. So this method you work by yourself at home. I'll teach you this alternate method. Okay. Now what you have to do is, so we have two equations here. Now solve the equations for A and B. Why A and B? Because we'll have to find A squared plus B squared. We have to find the value of A squared plus B squared. So write the equations one below the other. Use the elimination method and find the values of A and B. So multiply this equation and this equation by a suitable expression and eliminate one of the variables A or B. So if you eliminate A, you will find the value of B. Then what you do, you don't substitute. Again, write the equations one below the other. Multiply suitably. Like first, if you eliminated A, you would have found the value of B. Then you eliminate B and find the value of A. Do it like that. That'll be easier. You can substitute, but you try it like this. So write the equations like this, one below the other. Multiply the two equations by a suitable expression so that the variable A or B is eliminated. Okay, either A is eliminated or B is eliminated. If you eliminate A, you can get the expression for B. You got B, no? Okay, have it. Now again, write the original two equations one below the other. The original two equations given in the question one below the other. Again, multiply by suitable expressions. So if you B, so you will get the value of A. Now you have the values of A and B or the expressions for A and B. Find A square plus B square. So this method, I'll leave it to you. The alternate method is, online children, have you all learned this chapter? A pair of linear equations and two variables at school?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Then I'm sure all of you have understood what I just explained. That's one method. Now what I have here is, I square this one. We have A cos theta plus B sin theta is equal to 4, right? I square this on both the sides. So now why square? Why not cube? Because identities have power 2. Identity. See, we have sine and cos here. So if it is sine square theta and cos square theta, maybe we can use the identity. Now when it's sine and cos, okay, it's a different story. So if you have sine square theta and cos square theta, you can additionally use the identities. So we square. We have two equations given in the question, right? In the question, we have two equations. What are the equations? A cos theta plus B sin theta is equal to 4 is one equation. Then A sin theta minus B cos theta is equal to 3 is the other equation. What you do, you square the equations on both the sides and add. Square and add. That's all. You will get the result. You will be able to find A square plus B square. Two equations are given in the question. Square the equations and add the two equations. That's it. That will just take you to the answer. You will just get A square plus B square like that. So that's what you see here. Okay. So this is the equation given. We square on both the sides. So like this, how do you square it? We have two terms. Squaring a binomial. It's like x plus y the whole square. It's x squared plus y squared plus 2xy. Not to forget 2xy. X squared plus y squared plus 2xy. Okay, so you can see that. And when you square, see, A cos theta, when you square it, it is not A cos square theta. It is A square cos square theta. See, if you square ABC, square this one, it is not ABC square. When you square ABC, it is A square, B square, C square. If you have this expression ABC and you have to square it, it's not just putting a 2 here. Square that expression. So it's like this. Square it. So it is A square, B square, C square. In the same way, this is the first term. Square it. So it is not this. It is not just this. A cos square theta. Because sometimes we go wrong. It's A square cos square theta. Register this one. It's A square cos square theta. Similarly, b square sine square theta. Then the 2xy term will be 2 into a cos theta into b sine theta. So it will be 2ab sine theta cos theta. 2ab sine theta cos theta. So x plus y the whole square is x square plus y square plus 2xy is equal to 4 square 16. Okay, I've called this 1. Now take the next equation. There's a next equation given. Square it on both the sides. So it's like this. So now this is x minus y the whole square. So x square plus y square minus 2xy is equal to 3 square 9. I've called this 2. Now adding equation 1 and 2. Adding equations 1 and 2. So just add the left hand side, add the right hand side. Add the contents of the left hand sides and the contents of the right hand sides. So on the left hand side, what do you have? We have 16 here. Sorry, on the right hand side, what do we have? We have 16 and 9. So what is 16 plus 9? 25. So 25, see here, right? And on the left hand side, we have 3 terms in each equation. Here you have 1, 2, 3 terms. Here we have 1, 2, 3 terms. So you can see here 1, 2, 3, 4, 5, 6 terms. When you add the terms on the left hand side. So of the 6 terms, the middle terms 2ab, they get cancelled because they're the same with opposite signs. Cancels. Okay. And you are left with 4 terms. You are left with 4 terms. Okay. You are left with this one, a square cos square theta, b square sine square theta, a square sine square theta, b square cos square theta. Now, when you have 4 terms, you'll have to proceed by grouping. Group 2 terms and the other 2 terms, take out the common factor like that. You can group any 2. They should have a common factor, that's all. So I have grouped the terms which have, I have grouped these 2 terms which have a square in common and these 2 terms because they have b square in common. You can also group the terms that have sine square theta in common and the 2 other terms that have cos square theta in common. You can group it like that also. We have 4 terms, right? To proceed, we have to use grouping method. So in grouping method, what is the criteria? The first 2 terms must have something in common and the last 2 terms should have something in common. What is the, what is that I have used here in the presentation? I have grouped 2 terms which have a square in common and 2 other terms that have b square in common. But there are other things, no, sine square theta and cos square theta. So you can also group that. You can group this one and this one because they have sine square theta common. You can group this and this because they have cos square theta common. That way also you will get the answer. Okay. So like I have written like this. So I have written these 2 terms first because a square is common. Then these 2 terms, b square is common. So a square common and we have this in the bracket. B square common, this in the bracket. And what is this? 1 because sine square theta plus cos square theta is 1. Sine square theta plus cos square theta is 1. So it becomes a square into 1 plus b square into 1. So a square plus b square is 25. So if you group the other way, which are the terms that have sine square theta in common? A square sine square theta plus b square. A square sine square theta plus, tell me, b square sine square theta plus a square cos square theta plus b square cos square theta. So here we have grouped these 2 terms because they have sine square theta common. Here because they have cos square theta common. So what's common now? Sine square theta. So in the bracket, a square plus b square plus cos square theta is common. So in the bracket, a square plus b square. So the next step will be a square plus b square. We should write it once. A square plus b square, we'll write it once. Then in the other bracket, what should you write, Keshav? Continue. No, complete this. No, relax, actually. Look at the board and do. Yeah, Krishna, yes. That's all? Only sine square theta? Sine square theta plus cos square theta. Sine square theta plus cos square theta. Because this is common. A square plus B square is common. Should write it out once. Then you should write these two in the other bracket. Sine square theta plus cos square theta in the other bracket. That's how we factorize by grouping. Write this one once. And these terms, sine square theta plus cos square theta in the other bracket. All right, you got it now? Okay. So A square plus B square into sine square theta plus cos square theta is 1. This is 1. And you have 25 here. I didn't write it. You have 25 here. Is equal to 25. So A square plus B square is equal to 25. You can also group it like this. Yeah. You just go through this. This is very simple. I'm not explaining this. Go through. Turn off the light. ஒரு switch தான் ஆன் இருக்கும். அதை அணைச்சிருக்கேன். இல்ல இங்க உள்ள இருக்கு கண்டிப்பா. தேங்க்யூ. Okay. Now, if sine theta minus cos theta is 1 by 2, find sine theta plus cos theta. So, whenever, the question involves sine theta and cos theta, use this identity. A plus B the whole square plus A minus B the whole square is equal to 2 of A square plus B square. Remember this. Whenever in trigonometry, whenever the question involves sine theta and cos theta, in questions like these, okay, so here you're given the value of sine theta minus cos theta, and you're asked to find the value of sine theta plus cos theta. So like you're given A minus B, and you're asked to find A plus B, and that should be involving sine and cos. Look at the question. Sine theta minus cos theta, so like A minus B. And find the sine theta plus cos theta, like A plus B. You're given A minus B value, you have to find the value of A plus B. So make use of this identity. A plus B the whole square plus A minus B the whole square is equal to 2 of A square plus B square. We'll use this in a few other questions also, which involve sine theta and cos theta. So the start understood? So then you know the answer. If you use this identity, it will just take you to the answer. No effort. The effort is only to remember this identity. Identity you will remember. You should remember to relate or use this identity for a question like this. Give me a minute, online children. Yeah. Online children, my screen is visible, right?
Yes, ma'am. Yes, ma'am.
Okay. Yeah. So we have the value of a minus b, and we have to find the value of a plus b. So we make use of this identity, a plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. So one is you will have to remember this identity. Two is that you should remember to relate this identity to a question like this, which involves sine theta and cos theta. Given sine theta plus cos theta, find sine theta minus cos theta. Or given sine theta minus cos theta, find sine theta plus cos theta. In questions like this, you can make use of this identity. So that's it. If you remember the identity, so see here, I've written the identity here. All right. Now for A, use sine theta. For B, use cos theta. That's all. Write the identity. And for A, use sine theta. For B, use cos theta. A is sine theta. B is cos theta. A square, sine square theta. B square, cos square theta. That's all. Write the identity. And in place of A, use sine theta. And in place of B, use cos theta. All right. Okay, that's all. Then we have to find sine theta plus cos theta, right? So that means we'll have to find sine theta plus cos square theta. We'll have to find sine theta plus cos theta, which means we'll have to find sine theta plus cos square theta, and then find sine theta plus cos theta. So this one will remain. What's the value of this is given half. So half square is equal to 2 into what is sine square theta plus cos square theta? 1. Tell me all the three trigonometric identities. Tell me all the three trigonometric identities. Tell me all the letters from A through Z. அவ்வளவு கான்பிடண்டா சொல்லணும். Yeah. One more. Very good. Repeat. மாத்தி சொல்லிட்டீங்க. Cot square theta minus cosecant square theta is equal to -1. Cosecant square theta minus cot square theta is 1. மாத்தி சொன்னா it's -1. It's okay. மாத்தி சொல்லிட்டா say it's -1. Supposing you say tan square theta minus secant square theta and you don't want to go back and correct it, then say tan square theta minus secant square theta is equal to -1. Secant square theta minus tan square theta is 1. Tan square theta minus secant square theta is -1. Okay. So that's it. We have just substituted. See, in the moon expressions, of these three expressions, this is one. Easy. This one is given in the question. And this we have to find. எல்லாமே தெரிஞ்ச அப்புறம் என்ன கண்டுபிடிக்கணும்? அந்த மூணு expressions ஏதாவது ஒரு வேல்யூ தெரியாம இருக்கும். That's what we're finding. This is what we, that's it. Now it's just like solving an equation. So this one is as it is. And 1/2 the whole square on the other side will be -1/4. So 2 minus 1/4 LCM. Then this whole square, so it becomes square root. And it is square root of 7 by, what's the square root of 4? 2. So square root of 7 by 2. So, all right. Online children, any questions?
No, ma'am.
Okay. Tell me, what should we do here? What is x? This is the LHS, right? A square by x square minus b square by y square. So you'll have to take up this, work this and show that the value is 1. Yeah. Now a square you'll write as a square itself. By what is x square? A square sine square theta minus b square by what is y square? B square tan square theta, right? Correct? Now a square gets cancelled. B square gets cancelled. Now what's 1 by sine square theta? Cosecant square theta. And what is 1 by tan square theta? Cot square theta. And what is cosecant square theta minus cot square theta? 1. That's all. So left hand side. We'll have to take up the LHS. A square by x square minus b square by y square. So a square by x is a sine theta, the whole square, x square minus b square by y is b tan theta, then y square whole square. So it will be a square by a square sine square theta minus b square by b square tan square theta. So a square, b square cancels. 1 by sine square theta is cosecant square theta minus 1 by tan square theta is cot square theta. And by the identity, the value is 1. And that's the RHS. Tell me, quickly tell me something. Which identity? Is equal to 2 into is equal to 2 into a square plus b square. Why? Because in the question we have sine and cos. That's the first thing. And then we have sine theta plus cos theta. Okay, or cos theta plus sine theta. And we have to find or show that cos theta minus sine theta is something. So again, it's like we have sine and cos. In the question, we have sine and cos, and we have them like a plus b and a minus b. We are given a plus b. We have to find a minus b, right? Can you relate that? Here, this is a plus b. Is given root 2 cos theta, and you'll have to find or show that a minus b is equal to root 2 sine theta. That's it. So write the identity. Now for a use cos theta because see a minus b. So a is cos theta, b is sine theta. So use a, instead of a use cos theta and instead of b use sine theta in the identity. So a plus b, cos theta plus sine theta whole square. Am I clear, children? Please write the identity, and in the identity in place of a and b, write this identity. For a, replace cos theta. For b, replace sine theta. That's all. Now, this one is 1. Cos square theta plus sine square theta is 1. And cos theta minus sine theta, we have to find. Cos theta minus sine theta, we have to find. So this will come down as it is. Cos theta plus sine theta is root 2 cos theta. Substitute that. There are 3 expressions, 1, 2, and 3. This one, this one is a trigonometric identity. Its value is 1. This one we have to find. So that will come as it is. And this, the value is given to be root 2 cos theta. All right. So substitute. This one is root 2 cos theta square. This one as it is. Here 2 into 1. Now we have to find the value of this one. So have this on the same side. Transpose this. Transpose this. So after transposing, 2 is common. And then we have 1 minus. This one will come as it is. So here 2 is common. 1 minus cos square theta in the bracket. 1 minus cos square theta is sin square theta. And this one, the whole square. This one, the whole square is 2 sin square theta. So cos theta minus sin theta will be square root of 2 sin square theta. Square root of 2 sin square theta. So square root of sin square theta is sin theta. And this one, 2 remains under the square root. 2 remains under the square root. The square root of sin square theta is sin theta. So it comes out of the square root as sin theta. Square root of sin square theta is sin theta. But 2 remains under the square. So we proved that the value of cos theta minus sin theta is root 2 sin theta. Yeah, go through. Let's wait for 3 minutes. Any questions? Online children?
No, ma'am.
All right, good. Okay, similar question. So you can do this yourself. Similar. So here the cos theta plus sin theta is given, and you'll have to find cos theta minus sin theta. Oh, here also. Okay, so here also given the same thing, but a different value. I thought the opposite was given. Here also given the same thing, cos theta plus sin theta, but the value is root 2 sin theta. Slightly different. The value is different. Otherwise, the procedure is going to be the same. So I'll not. I don't have to. We don't have to do the see this again. You can help yourself later. Same identity. But because it is sin theta minus cos theta and sin theta, see here, it's sin theta minus cos theta here. So for A, use sin theta, for B, use cos theta. For A, look at that A minus B part. Don't look at the A plus B part. Look at the A minus B part. Because A plus B can be interchanged also. Cos theta plus sin theta is also sin theta plus cos theta. So what is important is, or sensitive is, that A minus B part. So look at A minus B and decide the value or the expression for A and B. Look at this one, A minus B. So what is A? Sin theta. What's B? Cos theta. Somebody's mic is enabled. Disable your mic. Now here, look at this one, A minus B. What is A here? Cos theta. B, sin theta. Don't go with this one. Don't go with that A plus B part. Go with the A minus B part. Am I clear? A is cos theta, B is sin theta. But here, A is sin theta, B is cos theta. Okay. Now we are given here, we are given the expression of the value for P. P is equal to secant theta plus tan theta. Okay. We'll have to prove that P square minus 1 by P square plus 1 is equal to sin theta. It will be given either ways. You understand like this. You will have to show that P square minus 1 by P square plus 1 is equal to sin theta. It's given show that sin theta is equal to P square minus 1 by P square plus 1. But we are given the expression for P, right? So we have to work with this part, not with sin theta. There's nothing to do. What will you do with sin theta? So show that sin theta is equal to P square minus 1 by P square plus 1. Whichever side you can work, that side you will have to take up. So here you have to take up P square minus 1 by P square plus 1, right? Take up that side, the RHS. And for P, use secant theta plus tan theta. And you work that, you should get sin theta as the answer. Okay. So let's start. The right hand side, RHS, is P square minus 1 by P square plus 1, correct? Is equal to what's P? Secant theta plus tan theta, the whole square minus 1 by secant theta plus tan theta, the whole square plus 1, correct? So secant square theta plus tan square theta plus 2 secant theta tan theta minus 1 divided by secant square theta tan square theta plus 2 secant theta tan theta plus 1. Now in the numerator we have minus 1, in the denominator we have plus 1. Now a group, see, like what minus 1 can give you a new result? Which ratio here minus 1 can give you a new result? Will secant square theta minus 1 give you a new result? Or tan square theta minus 1 give you a new result? Or 2 secant theta tan theta minus 1 give you a new result? Identity, using identities. See, new result, I mean, you know that cosecant square theta is 1 plus cot square theta, right? Cosecant square theta is equal to 1 plus cot square theta. So if there is 1, if you group 1 and cot square theta, 1 plus cot square theta, you can write cosecant square theta, right? In that sense, I'm asking. Minus 1 with what ratio will give you a new result? Secant square theta minus 1. Secant square theta minus 1. Not, see, secant square theta minus 1 is what? Tan square theta. But tan square theta minus 1, from that identity, you cannot write anything. Tan square theta minus 1. See here. Secant square theta minus tan square theta is equal to 1. So secant square theta minus 1 is equal to tan square theta. Secant square theta minus 1 is equal to tan square theta. So we'll group secant square theta minus 1 in the numerator and write the others as they look. We'll just do one change at a time because we don't know what else to do. We'll just do this change and see what happens because we don't know what to do with the others. All right. In the denominator, plus 1 and what will give you a new result? Secant square theta plus 1 or tan square theta plus 1 or 2 secant theta tan theta plus 1. Tan square theta plus 1. What's tan square theta plus 1? Secant square theta. You know you're quiet, right? You understand, right? Yeah. So secant. So what do we have? 1 plus tan square theta plus 1 is secant square theta. So we'll let the secant square theta as it is. Secant square theta as it is plus tan square theta plus 1 or 1 plus tan square theta, whatever. Then what's other? See, we are grouping these two. Then here we are grouping these two, tan square theta plus 1. Then plus 2 secant theta tan theta. Correct? Correct? Now what is secant square theta minus 1? Secant square theta minus 1 is tan square theta. There's again plus tan square theta. So 2 times, with this root here, 2 tan square theta plus 2 secant theta tan theta divided by, this is secant square theta. What is tan square theta plus 1? Secant square theta. So square theta plus secant square theta is 2 secant square theta plus 2 secant theta tan theta. Now what's common? There are only 2 terms now. There are only 2 terms in the numerator and 2 terms in the denominator. So what can you do with that? You can only take out the common factor. So what's common? 2 is common, tan theta is common in the numerator. In the denominator, 2 is common and secant theta is common. So do that. So you can see that here. Okay, so in the where we stop, sorry, so I think we're here, right? Correct. So 2 gets cancelled, and then on taking common, tan theta plus secant theta plus tan theta, they're the same expressions in the numerator and denominator, they get cancelled. So we have tan theta by secant theta, tan theta by secant theta. Tan is nothing but sine by cos divided by secant is nothing but 1 by cos. Then the division becomes multiplication. So 1 by cos will become cos by 1 or cos. Then cos and cos gets cancelled. So p square minus 1 by p square plus 1 is equal to sine theta. Right? Yeah, please go through the answer. No, this taking out common part, please go through. I told you 2 tan theta is common in the numerator and 2 secant theta in the denominator, right? So just go through this part again. See, I've used this division symbol so that it's easier to, work. Tan is sine by cos, then this division comes as it is. Secant can also be written as 1 by cos. Don't make division multiplication now. Division comes as division. What is the other way of writing secant theta? 1 by cos theta. You're writing the equivalent. So division is division. Secant theta, you can also write it as 1 by cos theta. Secant theta, you can also write it as 1 by cos theta. Yes or no? Yeah, so division is division only. Secant theta is 1 by cos theta. Now, in the next step, this division becomes multiplication. This division becomes multiplication. So we take the reciprocal. 1 by cos theta is cos theta. The reciprocal. The next step. Now cos and cos gets cancelled and the result is sin theta. Go through that. I can explain if I'm not clear. Children, any questions, any doubts related to that division sign? So tan theta divided by secant theta, right? What's tan theta? Sin theta by cos theta. This division as it is. Secant theta can also be written as 1 by cos theta. Next step, sin theta by cos theta as it is. Now we're changing this division to multiplication. Then what should you do? You should take the reciprocal of the next term. So we have 1 by cos theta. Its reciprocal is cos theta. Now cos gets cancelled and sin theta is answered. Correct? Similar this is. Similar, go through. Or you can just practice it now. Maybe in the last page, or if that's your, how many of you maintaining a separate notebook for every chapter? That's good. Yeah. Yeah. That's why I suggested. See, now when we, like switch between different chapters, it's easy to maintain. Otherwise, it would be clumsy. If you're maintaining one book, I told you, gave you this instruction when we started the classes. Yeah. So for both 9th and 10th, only for 7th and 8th, I asked them to maintain one book if it's okay for them. 9th and 10th, it's always better because when we do revision and all that, you'll have everything of one chapter in one book. So it's easy to revise. Yeah. Practices. Finish, Keshav? Got it? No, you practice it by yourself. Very good. What happened to your friend, Hariprana? He didn't tell you that he'll not come to the class today. Was he at school today? Saturday. So Keshav, tell me the next step for this. Supposing we have a square into x square plus y square plus b square into x square plus y square. What will be the next step? It's not related to this question. I'm asking you in general. No, tell me what I should write. A square x square. No. Yeah. Yeah. You must write this common factor once, x square plus y square. Write that once and write these two in the other bracket, a square plus b square. Okay. This is over. Online children, any questions? Any clarifications with regard to this proof or this answer? Okay, online children, use the emoji, raise your hand. Tessie, Prenu, Aragamai, Aniruddhan, Kamalika, Anugraha, Roshni, Niveda, Pratish. Veda is from, okay. All right, children, thank you. Okay. So here, if tan A is equal to n tan B, sin A is equal to m sin B, prove that cos square A is equal to m square minus 1 by n square minus 1. So that means you should take m square minus 1 by n square minus 1, work that and show that the result is equal to cos square A. It's not that you should always take the left-hand side and get the right-hand side as the answer. You can take the whichever side, wherever simplification is possible, you should take up that side. So the left-hand side is cos square A. What will you do with cos square A? Because you're given the values for m and n here, right? So you have to take up the RHS. M square minus 1 by n square minus 1. There you should substitute the expressions for m and n. and work that. And when you work, you will get cos square A. So since we are not directly given the expressions for m and n, you'll have to do little working and bring the values for m and n. Because it's given tan A is equal to n tan B. So n value is not given straight away, m value is not given straight away, right? So you can see here. So n is equal to tan A by tan B. Tan A means what? Always when you have other ratios, write it in sine and cos. So tan A is sine A by cos A, and tan B is sine B by cos B. If there's a doubt in this part, I'll just do it here. This one, well, it's tan A divided by tan B, right? Right? What's tan A? Sine A by cos A divided by what's tan B? Sine B by cos B. Now the division will become multiplication, right? So cos B will go to the numerator and sine B will come to the denominator. Cos B will go up and sine B will come down. So cos B up, and sine B down. That's what I've written here, student. So you can just take that one extra step. When you're not sure, it's better you give 1 or 2 extra steps and write it correctly than skipping them and going wrong. Then the whole thing is going to go wrong. Okay. Correct. Oh my God. Yeah. So then from the next one, we'll have to find the value for m. Okay. So we have sine. Are you having a remote control from there? Okay. Hello. So sine A is equal to m sine B. So m is equal to, my God. So m is equal to sine A by sine B, correct? M is equal to sine A by sine B, correct? Okay. So in these expressions, we don't have the values or the expressions for, in these equations, here and here, we are not given the value of m and n directly. So we'll have to work a little and find the value of n and m. Here, when you work n, we have it in tan, but we want it in sine and cos. So we write tan A as sine A by cos A and tan B as sine B by cos A. So this is n and this is m. Okay. Now substitute. Take up this one. What is m? This. So m square. So it will be sine square A by sine square B. Minus, okay, let me tell you something else. See, this is the numerator, this is the denominator. So you see the numerator here, m square minus 1 here, divided by, you see n square minus 1 here. For me, it's easier to explain like this than writing that division like this and then writing it down. For students also, I think this will be easier. So if you write a fraction and then again by another fraction, we may go wrong. Use this method. It looked clear and understandable. So I've written m square minus 1 here. This is the numerator. Then this one converts to division sign like this. And this n square minus 1 I've written here, n square minus 1. So what is m? This one. M square will be sine square A by sine square B. Minus 1 divided by n square. This one. So sine square A cos square B by cos square A sine square B. Minus 1. This is m square. We know m. This is m square minus 1. This minus 1 divided by this full thing is n square. This one is n square. Here we have n, no? This one square. So what will be n square? It will be like this. This is only n square. N square will be sine square a, cos square b, cos square a, sine square. Minus 1. Then we have to take the common denominator. So here sine square b is the common denominator. Here this one is the common denominator. All right. Then after that, reciprocal, right? Reciprocal division sign. So make this multiplication and take this up and bring this down. Correct? Now, see, actually, you can see that I've made some changes with this one. Now, why? The question is why. See, let me explain that. Now, what happens is, okay, let's say that we write this itself here. Let's say that we write the same thing, okay, this one itself here. Just give you that extra step here, okay. So, supposing the next step will be sine square a minus sine square b divided by sine square b into cos square a sine square b divided by sine square a cos square b minus cos square a sine square b. Okay, so like after the step between these two. This division becomes multiplication, and I've written the reciprocal of the next term as it is. Reciprocal as the terms look there. Now what happens? Sine square b and sine square b gets cancelled. Okay. Okay. Now we have cos square a here, right? And that only is the answer. Cos square is the answer. We have the answer there already. That means what? This and this should get cancelled. Because when you work m square minus 1 by n square minus 1, the answer should be cos square a. And we already have here cos square a, we already have cos square a. So that means this one and this one, they should be equal. There's no choice. They have to be equals. And you should show that they're equal and you should cancel it out. Already the sine square b is cancelled out. So what we do is, if you have to cancel this, 1 minute. What gets cancelled? Sine square b gets cancelled, correct? Now, can we see the answer here, cos square a? Yes. That means what? This expression in the numerator and this expression in the denominator must get cancelled. They are the same. Then only, no, we've already got the answer cos square a. That's how you need to interpret the situation now. So what do you have here? Sine square a minus sine square b, right? You don't have cos. So what I've done is I've written cos square b as 1 minus sine square b and sine square b, and cos square a as 1 minus sine square a. Why? Because if I have to cancel out this and this, here there's only sine. There is no cos. There's no cos there. There's only sine. So what we can do is cos square b can be written as 1 minus sine square b. And this cos square a can be written as 1 minus sine square a. That's why we have changed. Because we have got the answer, we have to cancel this one. Now you cannot cancel because they look different, but they're actually the same. So you should look. They must be the same because we already got the answer. So when you look at this, this expression has only sine, but here there is cos, no? So we change that cos to sine. That's what you see here. So I've written this cos square b as 1 minus sine square b, and this cos square a as 1 minus sine square a. While taking the reciprocal. Then when you multiply, sine square a into 1 is sine square a. Sine square a into sine square b is sine square a sine square b. And 1 into sine square b is sine square b. And sine square a into sine square b. Minus into minus is plus. So plus sine square a sine square b. Multiplying this one with this term and this term. Sorry, multiply this with 1, multiply this with sine square b. Multiply sine square b with 1, multiply sine square b with sine square b. And you get these 4 terms. Now, what do you see? Minus sine square a sine square b plus sine square a sine square b. See, these 2 terms gets cancelled. Minus sine square a sine square b and plus sine square a sine square b gets cancelled. So you're left with sine square a minus sine square b. Sine square a minus sine square b. So now that in the numerator gets cancelled. We have the same expression in the numerator and denominator, they get cancelled, and the answer is cos square. When I share this slide, I'll be sharing these images with you on WhatsApp for you to complete. When I do that, I'll include that step. Okay, I'll include that step. I'll make the correction. It's not wrong now, but if I include that, it will be more clear. I'll include that and then share it with you. Okay, so tell me, let's do it again. What is m squared? Well, it might take longer to work. We'll just see this again here, this step alone. After substituting m square minus 1, n square minus 1, I said common denominator, LCM. Then after LCM, this division becomes multiplication, and we'll have to take the reciprocal. When you take the reciprocal, when you take this up here, the sine square b and the sine square b will get cancelled. So you will have this cos square a in the numerator, and that only is the answer, cos square a. So when this one comes down, here, that and this should get cancelled. But here there is cos square b and cos square a. But here there's only sine square a and sine square b. There's only sine. So we write that cos square b and cos square a in terms of sine. So cos square b is 1 minus sine square b. Cos square a is 1 minus sine square a. So it will be multiplication, sine square a into 1 minus sine square b. Then this one is 1 minus sine square a into sine square b. So open the bracket. When you open the brackets, you will have 4 terms. This into this, this into this, this into this, this into this. So you'll have 4 terms. Take care of the signs also. Multiply the signs. Now, in the numerator, you can see this one into cos square a. So you can see this one into cos square a. Into cos square. Okay. In the denominator, 4 terms are there. These 4 terms. Now this one and this one are the same with opposite signs. Cancels. So you're left with sine square a minus sine square b. And that's what you have in the numerator, sine square a minus sine square b. So they get cancelled. And the answer is cos square. I remember I was supposed to do, or I had promised I'll do, we'll repeat water-based questions today. But this trigonometry, you need to practice. I thought Saturday this is. So you have time now till Thursday to practice, and you also have Monday holiday, I think, all of us. Right? So I thought if I do trigonometry, you will have sufficient time to practice and complete your classwork also. When compared to volumes and surface areas, this needs more practice. That's the reason why I thought I'll just finish off trigonometry. This is the last part of trigonometry, right? Proofs of this kind, I hadn't finished at that time because the presentation was not ready. So with this, trigonometry is completely done. I don't know if I think another presentation like this. I don't know if I'll be able to complete that. So if I'm not able to complete that today, we'll have one more session on trigonometry. But questions similar to this is the concluding part of trigonometry. Questions similar to this one is the concluding part of trigonometry. With this, we'll finish. So I don't think I will have to take up one more session for trigonometry because the presentation is really vast. I have one more after this. So. If secant theta plus tan theta is equal to 4. So always remember, if you know the value of secant theta plus tan theta. Okay, now MCQ answer. You should give me the answer instantly. What's the value of secant theta minus tan theta? Instant answer I want. Is equal to what? Online children, quick. What's the answer? Secant theta minus tan theta is equal to? Nobody remembers. 1. No. How 1? Secant square theta minus tan square theta is 1. Secant theta minus tan theta. Yeah?
Minus 1.
Minus 1 is tan square theta minus secant square theta. Tan square theta minus secant square theta is minus 1. Secant square theta minus tan square theta is equal to 1. No. I have told you this. No, you don't remember. Will be the reciprocal of this value, 1 by 4. It's easy to remember. How did you forget? See here. Secant square theta minus tan square theta is 1, right? Now, what is this? This is nothing but secant theta plus tan theta into secant theta minus tan theta is equal to 1, right? So the product of these two is always 1. That means their values must be the reciprocals of one another, right? Secant theta plus tan theta into secant theta minus tan theta is 1. The product of these two expressions is 1. That means they're reciprocals of one another, right? So if secant, when is the product 1? The product of 5 and 1 by 5 is 1. The product of 3 by 4 and 4 by 3 is 1. The product of any number and its reciprocal is 1. Don't consider 0. Don't say 0 into 1 by 0. Okay, so the product of a number and its reciprocal is 1. Yes or no? Yeah. So if secant theta plus tan theta is 4, what should be this so that the product is 1? It has to be 1 by 4. Then only the product is 1. Today's children, we don't show expressions whether we understand, don't understand. So it's so difficult for me to judge. Face reading is of no use now because no expression, understood, not understood, both same facial expression. I'm not able to interpret and I can't read your minds. I'm not a mentalist. I think now a teacher has to, be a mentalist. Understood? Or should I repeat the explanation? Got it. Okay. Secant square theta minus tan square theta is equal to 1. A square minus B square is equal to 1. So A plus B into A minus B is equal to 1. The product is 1. So if this value is 4, what should be this value so that the product is 1? It has to be the reciprocal. Then only the product is 1. Okay, otherwise you can solve it. This I'm explaining. Otherwise, you can solve it like this. What is secant theta plus tan theta 4 into secant theta minus tan theta is equal to 1. So secant theta minus tan theta is equal to 1 by 4. 4 will come for division to the other side, so 1 by 4. You can solve it like this and find. Similarly, if cosecant theta plus cot theta is equal to say 2, then cosec or say 2 by 3. Then cosecant theta minus cot theta will be equal to 3 by 2. Because same thing. Cosecant square theta minus cot square theta is 1. That means cosecant theta plus cot theta into cosecant theta minus cot theta is equal to 1. And if cosecant theta plus cot theta is 2 by 3 into 3 by 2 is only 1. So cosecant theta minus cot theta is 3 by 2. But if sine theta plus cos theta is 1 by 2, then sine theta minus cos theta is not 2 by 1. Because there the identity is not of the form a square minus b square. It is sine square theta plus cos square theta is equal to 1. So if sine theta plus cos theta is 1 by 2, sine theta minus cos theta is not 2 by 1, reciprocal. No, because the identity is not of the form a square minus b square, it's a square plus b square. In this case only I told you, you should use that identity. A plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. Use that identity to find. If sine theta plus cos theta is given and you have to find the value of sine theta minus cos theta, use that identity. It will not be reciprocals here because the identity is not a square minus b square. Sine square theta plus cos square theta. But the other two identities are of the form a square minus b square. Beyond this, you will have to, take efforts to remember. I'm clear? So what you should do is, the idea is simple here. So secant theta plus tan theta is 4. Okay. So what's the other equation you can write? In the question, they've given you only one equation. So you will write another equation. Secant theta minus tan theta is 1 by 4. In the question, one equation is given. Secant theta plus tan theta is 4. Now you can write another equation by yourself. Secant theta minus tan theta is 1 by 4. So now you can solve these two equations, right? And find the value of secant theta and tan theta. Like you can write the equations one below the other. And find the value of secant theta and tan theta, like linear equations. That's all. That's a procedure here. So what I explained, secant theta plus tan theta is 4. So secant theta minus tan theta is 1 by 4. The steps I've shown here. Now write the equations one below the other. This one is given to you in the question. Secant theta plus tan theta is 4. And this one, secant theta minus tan theta is 1 by 4. We wrote that. Not given in the question. So now eliminate. So 2 secant theta is equal to 4 plus 1 by 4. We all know how to solve, right? 2 secant theta is equal to 4 plus 1 by 4. So when you work that, you get secant theta is equal to 17 by 8. If secant theta is 17 by 8, it's because we'll have to find cos theta, no? So cos theta will be 8 by 17. That's all. We found cos theta. Now we have to find sine theta. We know this identity, sine square theta plus cos square theta is 1. And we know cos theta is 8 by 17. So substitute and find sine theta. All right? Yeah, go through. Please go through the answer. So you must remember the procedure. It's not, there's nothing to work. There's nothing much to work in this. Meaning work and work, practice and remember. Just understand how you have to handle the, answer. So you're given one equation. You can write another equation. Secant theta minus tan theta is equal to 1/4. So when you have two equations, solve them simultaneously. Write the equations one below the other and solve them. So when you try to do that, plus tan theta minus tan theta gets cancelled. So 2 secant theta is equal to 17/4. So secant theta is 17. This 2 will come down here, no? So 2 into 4, 8. So cos theta is 8/17. So we got the value of cos theta. Correct? Now we'll have to find the value of sin theta. So we know this identity. Or you can use a triangle. Okay, how do we use a triangle? If you mark this as theta, cos theta is 8/17. So adjacent by hypotenuse. Adjacent by hypotenuse. So by Pythagoras theorem, this will be 15, right? Yeah, by Pythagoras theorem, this is 15. So what's the value of sin theta? Sin theta is opposite by hypotenuse. So 15/17. So you can do it like this also. You know that when you have the value of one t ratio, you can find the values of the other t ratios using a right triangle. When you have the value of one t ratio, you can find the values of the remaining 5 t ratios using a right triangle. You can do that also. Online children, just a minute. Okay. I completed this one, right? Yeah, when you have the value of one t ratio, you can find the values of the other t ratios using a right triangle. Or you can use, here I've used this identity because we know the value of cos theta. So substituting the value of cos theta, you can find the value of sin theta. You can also do it like this. Okay. This is also a similar question. Secant theta plus tan theta is equal to P. So what is secant theta minus tan theta? 1/2. Secant theta plus tan theta is equal to P. So secant theta minus tan theta will be equal to 1/2. But don't make this mistake. If sin theta plus cos theta is equal to P, sin theta minus cos theta is not 1/P. To find sin theta minus cos theta, you should use the identity a plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. So here, secant theta plus tan theta is equal to P. Secant theta minus tan theta is 1/P. So solve the equations. You can find the value of secant theta. Then again write the same. Work this and find the value of secant theta. Okay, then again write the same two equations. Yeah, so here we have added the two equations. Now change the signs and subtract the two equations. What's the? Yes? Yeah. So plus minus, sorry, Yeah, plus minus minus plus plus minus. So this gets cancelled. So you can find tan theta. 2 tan theta is equal to p minus 1 by p, correct? Okay. So you found what now? Secant theta and tan theta. We have to find secant theta, tan theta and sine theta. Then use a right triangle. Or let me see how I've done. Or you can even multiply. Okay. Now is this part understood? You're given one equation in the question. You have written another equation by yourself. Add the two equations. You can find the value of secant theta. Subtract the two equations. So you will get the value of tan theta. So now you found the first two, secant theta and tan theta value you found. Now sine theta you can find using a right triangle. Or sine theta by cos theta is tan theta, right? Sine theta by cos theta is tan theta, right? Forgotten that? Sine theta by cos theta is tan theta. So sine theta is equal to what? Tan theta into cos theta, right? Let's see, what have we found already? Secant theta and tan theta we already found. Or what should we find? Sine theta. Okay. Secant and tan we already found. Now we have to find sine theta. Now we know that sine by cos is tan. When you cross multiply, sine is tan into cos. So tan value we have. And cos we don't have, but we have secant. So multiply, you will get sine theta. Sine theta by cos theta is tan theta. On cross multiplying, sine theta is equal to cos theta into tan theta. Tan theta, we have the value. Cos we don't have. But what is cos? Whatever, okay, whatever is the value of secant theta, reciprocal is the value of cos theta. You have the value of secant theta, right? So the value of cos theta is the reciprocal of secant theta. So put that here and find sine theta. That's all. Yeah, please go through. Go through. You understand, right? Taking the LCM, P is the common denominator, so it's P squared plus 1. And then that 2 will come for division, so it will become 2P. So add the two equations, then subtract the two equations. So like that you get the values for secant theta and tan theta. Then you can see here, sin theta by cos theta is tan theta. So sin theta is tan theta into cos theta. So what is cos theta? This is secant theta. So cos theta will be 2p by p square plus 1. So sin theta is tan theta. Where is tan theta? This is tan theta. Into cos theta. This is cos theta. So 2p cancels, p square minus 1 by p square plus 1. Right? If secant theta is equal to x plus 1 by 4x, then prove that secant theta plus tan theta is 2x or 1 by 2x. We are given only the value for secant theta. Secant theta is x plus 1 by 4x. But we have to prove, or you'll have to show that secant theta plus tan theta is 2x or 1 by 2x. Now, we have the value of secant theta, right? How can you find secant theta plus tan theta? Only if you have the value of tan theta. If you have to find a plus b, you should know the value of a and b. So here you have to find secant theta plus tan theta. You're given the value or the expression for secant theta, but tan theta is not given. So you should find for tan theta. And for tan theta, you should get two values because secant theta is only one value here. For tan theta, you should get two values. Only then you can show that secant theta plus tan theta is 2x or 1 by 2x. If you have only one value for tan theta, then you'll get only one value for secant theta plus tan theta. If A is 3 and B is plus or minus 2, then A plus B will be A is 3, B is plus 2, so plus 2, so 5, or A plus B will be A is 3 plus B is minus 2, so 1. Secant theta is only one value. But you should show that secant theta plus tan theta, two values, 2x or 1 by 2x. So, like A is 3, but you should show that A plus B can take two different values. That means B should have two values, right? Only then, if A has only one value and B also has one value, then A plus B will have only one value. Okay, so all this you can interpret. When you read the question, you can just gather all this. Now, it's easy to find tan theta. Given secant theta, it's easy to find tan theta because secant square theta minus tan square theta is 1. Secant square theta minus tan square theta is 1. So, secant square theta substitute minus tan square theta is 1. So, when you work that, you can find the value of tan theta. Value of the expression for tan theta. Right? That's all. Then once you find tan theta, you'll get two values for tan theta. So find secant theta plus tan theta. Got it? So secant theta so see here. Secant square theta minus tan square theta is 1. So tan square theta is secant square theta minus 1. Secant square theta minus 1 is tan square theta. Tan square theta is secant square theta minus 1. So tan square theta, secant square theta minus 1. So tan square theta is, excuse me, x plus 1 by 4x the whole square minus 1. All right. Now this 1 can be written as, 4 into x into 1 by 4x. See, x and x cancel, it's 4 and 4 cancel. Okay. All right. So I was telling you that 1 can be written as 4 into x into 1 by 4x, 4ab. Okay. So you can see this x and x cancels, 4, 4 cancels, so it's 1. So 1 can be written in the form 4ab, 4 into, this is a, this is b. So 1 can be written in the form 4 into a into b. 4 into x into 1 by 4x is 1. So now use the identity. I think just come here and see my screen, no, because there's no point wasting time in fixing that. Just come set. The girls can come to the side, the boys the side. Have a look at the screen from my laptop. You're almost going to finish. 10 more minutes. Just stand so that just turn off the camera. I think it's okay. You're not. Yeah. Can you see my screen? Okay. Yeah. You can, right? Okay. So now this is of the form a plus b the whole square minus 4ab. A plus b the whole square minus 4ab is a minus b the whole square. This identity, a plus b the whole square minus a minus b the whole square is equal to 4ab. A plus b, oh, okay. Then maybe you can go back. Yeah. Sorry. So a plus b the whole square minus a minus b the whole square is 4ab, right? And now this is of the form a plus b the whole square minus 4ab. So what is a plus b the whole square minus 4ab? It's a minus b the whole square. It's a minus b the whole square. So use this identity. And so you'll have to write 1 in the form 4ab. So see here, I've just explained the identity here. So this is a plus b whole square. So write that tan square theta is equal to x plus 1 by 4x the whole square minus, write this 1 in the form 4ab. 4 into a into b. But you're not, it's still 1 only. You're just writing it in a different way, but the value is still 1. See, it's 1. And why are we doing that? Because we can use the identity. A plus b whole square minus 4 into a into b. No, we'll not waste time. Sorry, we'll not go back even if it comes. Yeah. Okay, so there's nothing but a plus b the whole square minus 4ab is nothing but a minus b the whole square. So you see here a minus b x minus 1 by 4x the whole square. So tan square theta is equal to x minus 1 by 4x the whole square. So tan theta is equal to plus or minus square root of x minus 1 by 4x the whole square. So it's like the square and the square root, they get cancelled. So tan theta is equal to plus or minus x minus 1 by 4x. So that means tan theta is positive x minus 1 by 4x or tan theta is negative x minus 1 by 4x. So we have two values for tan theta. Now we'll have to find secant theta plus tan theta. So when tan theta is this value, then secant theta plus tan theta will be, this is secant theta, and this is tan theta plus tan theta. So plus 1 by 4x minus 1 by 4x cancels, x plus x is 2x. And when tan theta takes this value, then secant theta plus tan theta is equal to, this is secant theta, plus tan theta is this one here. So multiply the signs. It will be minus x and minus into minus plus. It will be minus x, minus into minus plus. So minus x plus 1 by 4x. So here x and minus x cancels. 1 by 4x plus 1 by 4x. 1 by 4x plus 1 by 4x. The common denominator is 4x. So 1 plus 1. So 2 by 4x. 2 by 4x means 2 ones are 2 twos are. So 1 by 2x. 1 by 2x. So in this case, secant theta plus tan theta is 1 by 2x. So we have proved that secant theta plus tan theta can be 2x or 1 by 2x. So how do you remember this answer? We are given the expression for secant theta, and we have to find the expression or expressions for secant theta plus tan theta. Secant theta you have, tan theta you don't have. So you should find tan theta first. And how do you find tan theta? Using the identity. How do you find tan theta? Using the identity secant square theta minus tan square theta is 1. All right. And when you substitute, this looks like a plus b the whole square. So you want to write this as minus 4ab. Because this is a plus b the whole square and there's a minus here. So the identity comes to your mind and you want to show this as 4ab. So what is 4ab? 4 into, this is a and this is b. Yeah, 4 into a into b. So a plus b the whole square minus 4ab is a minus b the whole square. X minus 1 by 4x the whole square. So tan square theta is this one. So tan theta will be plus or minus square root of this value. So like this, you get two values for tan theta. So you're given tan theta. Now you found the values for, sorry, we are given secant theta, and we have found the values for tan theta. Oh, just fine. See, they asked me to find secant theta plus tan theta. So when you take this as the value of tan theta, find secant theta plus tan theta. Next, when you take this as the value for tan theta, find secant theta plus tan theta. All right. What we'll do, just you can see the board now. You can engage, just stand here and look at the board. If it goes up, we'll just again go back and sit. I'm sorry for the inconvenience, all of you. Sticker. We'll understand this and wind up the session for today. Just go through this answer. I just need to make a phone call. Okay. So in this one, we have two equations. A secant theta plus B tan theta plus C is 0. P secant theta plus Q tan theta plus R is 0. Whenever we have two equations, we can solve them. Okay. So write the equations one below the other and solve to find the values for secant theta and tan theta. Then you know this identity, secant square theta minus tan square theta is 1. So substitute and you will get this answer. Meaning you'll be able to prove this result. Not answer, sorry. You'll be able to prove this result. That's the idea. That's all, finished. When you see this question, you should just, this is the line which you should tell yourself. I'm given one equation, another equation. So write the equations one below the other and solve the two equations to find the values for secant theta and tan theta. Secant theta and tan theta. So see here, we found tan theta, we found secant theta. Okay. Then make use of this identity. Secant square theta minus tan square theta is 1. So secant theta, substitute the value. Tan theta, substitute the value. And when you work this, you'll be able to prove this result. Finished. Now let's see how to solve. So I've transposed C. So minus C you can see here. And this plus R, minus R. So these are the two equations given in the question. And here you can see them with C and R taken to the other side. Now, you can find anything first. You can find secant theta first or tan theta first. So I have multiplied the first equation with P and the second equation with A. So when I do this, this gets cancelled. AP secant theta. Okay, so you multiply and then you have to change the signs. Because this is AP secant theta, this is also AP secant theta. You cannot cancel, right? So you'll have to change the signs. Correct? You'll have to change the signs. So I've changed the signs throughout. So this gets cancelled. So BP tan theta minus AQ tan theta. BP tan theta minus AQ tan theta is equal to, this is plus AR minus CP. AR minus CP. I've written the two equations, multiply the first one with P, second one with A. And these are the new equations. But you cannot cancel, though they look alike, you cannot cancel because they have the same sign. So we change the signs throughout and then we cancel this. So we've cancelled, we've eliminated secant theta. So now you can find the value for tan theta. So BP tan theta minus AQ tan theta is equal to, this is positive, no? AR minus CP. So here tan theta is common. Tan theta is common. So you'll get in the bracket BP minus AQ is equal to AR minus CP. So tan theta is equal to AR minus CP by BP minus AQ. Finish. We got tan theta. Now again write the equations and multiply with suitable variables to eliminate tan theta. So here what do you have? B tan theta. Here Q tan theta. So this should become BQ and this also should become BQ. So this should become, because tan theta and tan theta. This is B, this is Q. So this should become BQ. This also should become BQ, right? So this is B. So you multiply that with Q. We have B here. So multiply by Q. Here we have Q. So multiply this one with B. So the first equation will be A into Q, AQ secant theta, B into Q, BQ tan theta is equal to minus C into Q minus CQ. And the second equation, B into P, BP secant theta plus B into Q, BQ tan theta is equal to minus R into B minus BR or minus RB. Again, BQ tan theta, BQ tan theta. You cannot cancel, they are alike, but you cannot cancel because they should have the opposite signs, right? So we change the signs throughout. I've changed the signs throughout. BQ tan theta minus BQ tan theta gets cancelled. So here AQ secant theta minus BP secant theta. AQ secant theta minus BP secant theta is equal to, this is positive. So write that positive thing first. BR minus CQ. BR minus CQ. This is positive, no? We have changed the sign. Minus BR is plus BR. So BR minus CQ. Right? So now secant theta is common. Secant theta common. So in the bracket, you will get AQ minus BP is equal to BR minus CQ. So secant theta is equal to BR minus CQ by AQ minus BP. So we found the expression of the value for tan theta and secant theta. Now you should write this identity by yourself. Nowhere it is specified that you should use this identity. Because you have the values for tan and secant, you must make use of this identity. Now substitute secant theta, substitute tan theta, substitute, and secant square theta, tan square theta. So now it will become square take the squares separately for the numerator and denominator like this, correct? Correct? And then the denominator is the same. You can, okay, the denominator is not the same. Here you have BP minus AQ. But remember that A minus B the whole square and B minus A the whole square are the same. A minus B the whole square is the same as B minus A the whole square. A minus B, B minus A, not the same. But A minus B the whole square and B minus A the whole square, both are the same. So here we have BP minus AQ the whole square. No, you can also write it as AQ minus BP the whole square. Why? Because here we have AQ minus BP. So we want the denominators to be the same. Here, since we have AQ minus BP the whole square, here we have the same thing but opposite order. BP minus AQ we have. So write this also as AQ minus BP. the whole square. So common denominator, AQ minus BP, the whole square is common. So then we have these two in the numerator, the minus sign in the middle, and cross multiply. Cross multiply. Cross multiply. So we'll have this one minus this one is equal to this one. And that's the result. See, PC is a CP, all that we understand. This is PC here, but we have CP here. That's fine. And here it's QC, but I've written CQ. Maybe you can write one more step with that. So that means BR minus, we have QC in the question. So CQ is QC whole square minus, we have PC there, the question. So CP is PC minus AR, the whole square is equal to AQ minus BP, the whole square. Understood? Any questions? Okay, take your seats. We'll wind up. Online children, any questions?
No, ma'am.
All right. So all that we have discussed in today's session, the images will be shared with you on WhatsApp. Please complete the same in your tuition notebook, your trigonometry tuition classwork notebook. Make sure it's completed by the next class. All right. Okay. All right, children. So that's it for today's session. Thank you so much. Online children can leave the call. Good night. Thank you,
Thank
children.
you,
Good
ma'am.
night. Thank you. Good night. Thank you, children. Good night.